Hey everyone, welcome to the channel, and today I'll be walking you through the standard steps to troubleshooting as a network engineer. Now, these steps are not only applicable to tech field or network engineering field, it is very much applicable in any field as long as you're troubleshooting, solving problems, think ticketing and the likes, you would find this really helpful. So if you're interested in learning these troubleshooting steps, and also if you want to see how they could possibly be applicable in this network-based scenario, let's just go straight into it. All right. So depending on the scenario and depending on your familiarity with the network, it is very important that you are able to, number one, identify the problem. Identify the problem. So in this step, you want to ask questions. You want to be familiar with the environment. You want to understand what is currently going wrong. You want to understand what they could have possibly done on the system after things have gone wrong. You want to know how long things have gone wrong, the last configuration, the last update made. You want to gather as much knowledge as you can to understand what is currently going on in the system. You cannot solve a problem you don't understand. And that takes us to our next step, which is to establish theory of probable cause. So in this step, right, you're trying to, this is where your expertise comes in, this is where your experience, this is where your knowledge comes in. So based on this scenario, based on the problem we have at hand, what are the probable causes? What is like, what could possibly be leading to this issue? For example, in this scenario, I see this is a layer 3 problem. So if they tell me, hey, the problem, step one, identifying the problem is maybe branch one on being unable to send packets or receive packets from the headquarters. I already know, okay, this is a network problem, network layer problem. This is a layer 3 problem, and I can see the routers, right? So I know this is a routing problem. So you could ask yourself, okay, what are the possible issues that could go wrong in layer 3 of a network model, right? So I know it could possibly be a misconfigured IP address. It could be a port that is administratively down. It could be, routing from one branch to the other. It could be an incorrect subnet mask. It could be an incorrect subnet mask here. It could also be, physical cabling, right? We could have a problem with the physical cabling. So at this point, you want to guess, right? You're more or less guessing what the problems could be based on your experience in that domain. And takes us to the third step, which is to test theory of probable cause. Oh, sorry. So in this step, based on everything I've just highlighted, I want to check if those are the issues. So the first thing I do, in this scenario, I check the IP address. Is it correctly configured? If it is, I take note. If it's not, I also take note. I check the physical cabling. Is everything, properly plugged in appropriately? I check if it's good, I take note of that. I also check the routing. Is everything being routed properly? I take note of that. I also check the subnet mask. Do we have a wrong subnet mask here? I take note of that. I check the ports. Is everything working fine there? Is it administratively up or down? I also take note of that. So here basically you are everything you've theorized, you're testing it out to confirm which is which. And then you go straight to your fourth step, which is to establish a plan of action and implement solution or solutions depending on the scenario. So right here, you want to establish. So now that I know what is going wrong in the system, I want to establish a plan, which is number one, I'm going to be correcting this IP address. I'm going to be configuring a proper subnet mask. I'm going to be turning on this port, and also I'm not going to be touching anything else, right? So that is my plan of action. And implement solution, I would actually go into the system and do these things one at a time. This helps me, okay, it helps me remember my plan, right? Having that plan of action helps you remember what it is you want to do, so you don't forget, because you could forget, you could have it in mind and then your memory fails you if you don't have a plan of action. But having a plan of action helps you not only in solving the problem, in also documenting the problem, which takes us, and then we go straight to the fifth step, which is to test and verify full, very important, system functionality. So in this step, we are testing everything you have done, right? So you've corrected everything, you've corrected this, corrected that. You want to test, right? You want to test, first of all, branch one successfully, talks to the headquarters. And this was the initial problem, right? But you could just test this and say, oh, you're done. No, you're not done. You also want to check branch two, ensure it communicates with three. Check branch three, ensure it communicates with sorry, this is two, ensure two communicates with three, three communicates with the headquarters, one, three can communicate with branch one, and maybe branch two can also communicate with the headquarters. So you want to make sure everything works as expected. You don't want to be the problem. You don't want to introduce more problem to the system than it already had. So that is basically you testing full system functionality. And then lastly, you want to document so you're documenting three things: your findings, actions, and outcome. Outcomes. So you're basically documenting everything you figured out was wrong with the system: the IP address, the ports, the routing, the physical cabling, the subnet mask. You're documenting your findings. Also, you're documenting your action. So I fixed, everything you reconfigured, everything you turned on, everything you fixed. You're also documenting that. And lastly, you want to document the outcomes, which is what we have here. Okay, you could document branch one now communicate with headquarters. I also confirmed branch one and two communicate, two and three communicate, three and headquarters communicate, inter-branch communication basically, and everybody being able to fetch resources from the headquarter. So that is you documenting the outcomes. And now it's very important I also know that step two to step five is not linear. You don't just go from, establishing theory to testing and then, implementing solutions and testing functionality. Sometimes when you get to step five, things might not work as expected, and you have to go back to the drawing board. And the drawing board being number two, you establish new set of probable cause, right? So if one and two is communicating and the headquarters, but three and branch one is not communicating, I need to understand why they're not communicating. I'm going back to number two. I'm going to test my theory, I'm going to implement solutions, and I'm going to test functionality. If it doesn't work, I go over to two again. So this step is very recursive. It's more or less like going in a loop until you have your desired outcome. So just have it in mind: step two to step five, it's not linear, it's recursive. And yeah, so these are the standard steps to troubleshooting as a network engineer. You want to be able to identify the problem, you want to be able to establish theory of probable cause, you want to be able to test the theory, you want to establish a plan of action, you want to implement solutions, right? You want to test and verify full system functionality, and lastly, you want to document your findings, actions, and outcomes. Yeah, that's it. So if you enjoyed this video, give it a thumbs up. If you want me to make more, if you want me to address more complex in networking scenarios or networking projects, also let me know in the comments. In the next video, I would actually be working on this project and fixing this or troubleshooting this problematic network. So if you're interested in that, give me a follow and subscribe to the channel. I would see you in the next one. Thanks for watching.